Hello there, welcome to the video series on following along with the LLVM tutorial on LLVM.org. Okay, so we're at the end, not the end, sorry. We're in the middle of chapter 4 where we're trying to get the optimizer set up, and in the last video I had problems getting their code example to compile. Now, at first I had troubles getting my code to compile, and then I had trouble getting their code to compile. And I figured that out, and the way I got it to finally compile was I simply took every single static library under their lib directory and appended it to the command line by using this star.a. And with that change, I was able to get their version of the code to compile. So now I'm going to apply this to my code, which I did. And when I applied it to my code, it still didn't compile. It had some errors. So now I'm going to try to solve those errors by using their code as the working version and my code as the non-working version. We're going to do a bug sandwich on it. If you're not familiar with the bug sandwich, I documented it at debugschool.com as one of the videos there. Bug sandwich. So if you're interested in learning more about the bug sandwich technique, debugschool.com is where you can learn more about it. I have like a about 15-minute video that I created to explain it. But you could also just watch me try to do it. So when I try to build my program, I get these 6 errors. But I know that's not supposed to happen because their version does the same thing and their version compiles. So I'm gonna basically, the bug sandwich is like I'm gonna compare the good version of the code versus the bad version of the code. And at the moment, their version is the good version of the code. I'm gonna try to figure out what is the difference between them, or what's the key difference that makes one of them work and the other one not work. Okay, so the place where the error is actually this run function, I believe. Yes, it says too few arguments to the function call, but I think it's matching it against the signature of the path manager, which I'm not supposed to use the path manager. I'm supposed to use the function path manager. I'm going to look at their code to see how their code has it, because there might be suspicious stuff in there maybe. Oh, it's their code 04 that I want to be looking at. I have 2 different versions of their code. Okay, they have this line of code is the same as far as I can tell. It has one, but perhaps I should look at how they defined the static variable. Oh, it should be make unique to a function path manager. Oh, the legacy function path manager. Okay, got it. I swear I copied that line from them. They didn't update this. If that's the problem, they should update that. Let's see if this fixes it. I get more errors than before. We still have this error, interestingly, but now I have a few more errors. Okay, and it doesn't. Oh, Probably because I have to match this as well. Let me check the version just in case. Yes, that's how they have it. Yes, that worked. All these are warnings, and I'm gonna ignore them. But because they are warnings only and no errors, that does mean it worked. So I'm gonna test it now. Okay. So with these optimization passes, supposedly, if I put in this code, then I should get this simplified output, which only performs one add. Whereas previously, without the optimization manager, there was actually 2 adds here. So let's try that. And yes, there's only 1 add now. Perfect. So the optimization worked. Now the tutorial didn't explain that much about what it actually did, but it's basically just said, yeah, there's these magic potions you can sprinkle onto your compiler, and then it'll, if conditions are right, it'll magically make your code smaller and faster. Yeah, so it saved a floating point add instruction on every single execution of this function, which is cool if this function gets executed a lot. LLVM provides a wide variety of optimizations that can be used in certain circumstances. Some documentation about the various passes is available, but it isn't very complete. Another good source of ideas can come from looking at the passes that Clang runs to get started. The op tool allows you to experiment with passes from the command line so that you can see if they do anything. Now that we have a reasonable code coming out of our front end, let's talk about executing it. Great. So that completes the first half of chapter 4. I'm gonna stop this video here, and the next one we'll do the section called adding a JIT compiler.